Propene, also known as propylene or methylethylene, is an unsaturated organic compound having the chemical formula C3H6. It has one double bond, and is the second simplest member of the alkene class of hydrocarbons. Properties: at room temperature and atmospheric pressure, propane is a gas, and as with many other alkenes, it is also colorless with a weak but unpleasant smell. Propane has a higher density and boiling point than ethylene due to its greater mass. It has a slightly lower boiling point than propane and is thus more volatile. It lacks strongly polar bonds, yet the molecule has a small dipole moment due to its reduced symmetry. Propane has the same empirical formula as cyclopropane, but their atoms are connected in different ways, making these molecules structural isomers. Occurrence in nature: propane is found in nature and is a byproduct of vegetation and fermentation processes. Propane has been detected in trace amounts in the lower atmosphere of Titan. On September 30, 2013, NASA announced that the Cassini orbiter spacecraft, part of the Cassini-Huygens mission, had discovered small amounts of naturally occurring propane in the atmosphere of Titan using spectroscopy. Production: propane is produced from fossil fuels petroleum, natural gas, and, to a much lesser extent, coal. Propane is a byproduct of oil refining and natural gas processing. During oil refining, ethylene, propane, and other compounds are produced as a result of cracking larger hydrocarbon molecules to produce hydrocarbons more in demand. A major source of propane is naphtha cracking intended to produce ethylene, but it also results from refinery cracking producing other products. Propane can be separated by fractional distillation from hydrocarbon mixtures obtained from cracking and other refining processes. Refinery-grade propane is about 50 to 70%. A shift to lighter steam cracker feedstocks with relatively lower propane yields and reduced motor gasoline demand in certain areas has created an imbalance of supply and demand for propane, and on-purpose production methods are becoming increasingly significant. On-purpose propylene production technologies include, olefin metathesis, also known as disproportionation, is a reversible reaction between ethylene and butenes in which double bonds are broken and then reformed to form propane. Propane yields of about 90 Wt% are achieved. This option may also be used when there is no butene feedstock. In this case, part of the ethylene feeds an ethylene dimerization unit that converts ethylene into butene. Propane dehydrogenation converts propane into propane and byproduct hydrogen. The propane from propane yield is about 85 m%. Reaction byproducts are usually used as fuel for the propane dehydrogenation reaction. As a result, propane tends to be the only product, unless local demand exists for hydrogen. This route is popular in regions, such as the Middle East, where there is an abundance of propane from oil-gas operations. In this region, the propane output is expected to be capable of supplying not only domestic needs, but also the demand from China, where many PDH projects are scheduled to go on stream. However, as natural gas offerings in the USA are significantly increasing due to the rising exploitation of shale gas, propane prices are decreasing. Chemical companies are already planning to establish PDH plants in the USA to take advantage of the low-price raw material obtained from shale gas. Numerous plants dedicated to propane dehydrogenation are currently under construction around the world. There are already 5 licensed technologies. The propane dehydrogenation process may be accomplished through different commercial technologies. The main differences between each of them concerns the catalyst employed, design of the reactor and strategies to achieve higher conversion rates. Methanol to olefins: methanol to propane converts synthesis gas to methanol, and then converts the methanol to ethylene and/or propane. The process also produces water as byproduct. Synthesis gas is produced from the reformation of natural gas or by the steam-induced reformation of petroleum products such as naphtha, or by gasification of coal. A large amount of methanol is required to make a world-scale ethylene and/or propane plant. High-severity fluid catalytic cracking uses traditional FCC technology under severe conditions in order to maximize the amount of propane and other light products. A high-severity FCC unit is usually fed with gas oils and residues, and produces about 20–25% propane on feedstock together with greater volumes of motor gasoline and distillate byproducts. Olefins cracking includes a broad range of technologies that catalytically convert large olefins molecules into mostly propane and small amounts of ethylene. Propane production has remained static at around 35 million tons from 2000 to 2008, but it has been increasing in East Asia, most notably Singapore and China. Total world production of propane is currently about half that of ethylene. Uses: propane is the second most important starting product in the petrochemical industry after ethylene. It is the raw material for a wide variety of products. Manufacturers of the plastic polypropylene account for nearly two-thirds of all demand. Polypropylene is, for example, needed for the production of films, packaging, caps and closures as well as for other applications. In the year 2008 the worldwide sales of propane reached a value of over $90 billion. Propane and benzene are converted to acetone and phenol via the Cumin process. Propane is also used to produce isopropanol, acrylonitrile, propylene oxide and epichlorohydrin. Reactions: propane resembles other alkenes in that it undergoes addition reactions relatively easily at room temperature. The relative weakness of its double bond explains its tendency to react with substances that can achieve this transformation. Alkene reactions include 1. Polymerization, 2. Oxidation, 3. Halogenation and hydrohalogenation, 4. Alkylation, 5. Hydration, 6. Oligomerization, and 7. Hydroformylation. Propane will react with NBS to form the aryl halide 2-bromopropane. The use of NBS, instead of hydrobromic acid, allows the substitution of hydrogen from the methyl functional group adjacent to the double bond, instead of the addition of hydrogen and bromide to the double bond as stated above in a hydrohalogenation reaction. Environmental safety: propane is produced naturally by vegetation, particularly certain tree species. It is also a product of combustion, from forest fires and cigarette smoke to motor vehicle and aircraft exhaust. It is an impurity in some heating gases. Observed concentrations have been in the range of 0.1–4.8 parts per billion in rural air, 4–10.5 ppb in urban air, and 7–260 ppb in industrial air samples. In the United States and some European countries a threshold limit value of 500 parts per million was established for occupational exposure. It is considered a volatile organic compound and emissions are regulated by many governments, but it is not listed by the U.S. Environmental Protection Agency as a hazardous air pollutant under the Clean Air Act. With a relatively short half-life, it is not expected to bioaccumulate. Propane has low acute toxicity from inhalation. Inhalation of the gas can cause anesthetic effects and at very high concentrations, unconsciousness. However, the asphyxiation limit for humans is about 10 times higher than the lower flammability level. Storage and handling: since propane is volatile and flammable, precautions must be taken to avoid fire hazards in the handling of the gas. If propane is loaded to any equipment capable of causing ignition, such equipment should be shut down while loading, unloading, connecting or disconnecting. Propane is usually stored as liquid under pressure, although it is also possible to store it safely as gas at ambient temperature in approved containers. Pharmacology: propane acts as a central nervous system depressant via allosteric's agonism of the GABA receptor. Excessive exposure may result in sedation and amnesia, progressing to coma and death in a mechanism equivalent to benzodiazepine overdose. Intentional inhalation may also result in death via asphyxiation. See also, Los Alfax disaster, inhalant abuse, 2014 Kaohsiung gas explosions, references.